Hello again. Here in this video, we're going to talk about section 1.3, which is about lines in the plane and slope. So I expect you to be decently familiar with, these concepts that we're going to talk about in this section, but reviews are always good. So yeah, we're going to review how to write equations of lines, what slope means, and go through some applications, and then we will also look at a review of parallel and perpendicular. So there are many ways that you can write equations of a line. There's something called standard form, there's something called point slope form, and you can use those if you want. The slope intercept form is the way that we tend to see lines written more frequently, and so that's the way that I'm going to stick with writing them throughout the semester. So equations of lines, we'll just say, can always be written in this way. That is slope intercept form. So that looks like y equals mx plus b. Okay, again, this is slope intercept form. And the reason that it's called slope intercept form is because this value of m, which will be a number when we have an actual equation of a line, tells us the slope. And the value of b, which again will be a number when we are looking at an actual equation of a line, this tells us the value of the y-intercept. Right? Because when you plug in a 0 for x, which is how you find the y-intercept, this term cancels out and you just get y equals b. Okay, so let us review some things about slope. So I will go through 4 different kinds of lines with you. The first example I've got here is y equals 2x minus 3. Now the slope, we can just pinpoint out, just kind of take that out of the equation here, right? That's just going to be the place, the thing that's multiplied by the x. It's already written in y equals mx plus b form, so the slope here will be 2. And the y-intercept is what is in place of the b, including the sign. So the y-intercept here will be not -3, but we could write that as 0, -3. All right, now here's how we might graph something given in this form. Here's what the graphical interpretation of this algebraic equation would look like. Okay, so let's set up some axes here. Let's label them x and y. Okay, we would kind of quote unquote start at the y-intercept. So I'm just going to label, down here at -3, here's the y-intercept. Okay, and then to find another point that we get to, I'm just going to label some things on the x-axis here. And just everything else in case we need it. To get to another point, we use the slope. And so recall that this slope number here can be thought of as rise over run, or change in y over change in x. And even though it's like 2 over 1, we can view this, even though it's just 2, we can view this as 2 over 1. Okay, so like we rise 2 and run 1. So run goes with x and rise goes with y. So we're going to go up 2 and over 1 to find the next point that lies on our line. And so that point is going to be right here. Then we can find another one. We'll go up 2 over 1, and so that's right here. Another one up 2 over 1, and so that's right here. And we can connect all of these together to get a graph or a picture of this line. Okay, and again, just to kind of show where this slope comes into play in the graph, let's just draw in here, right here. From this point to that point, we have a run of 1 and a slope of going up 2, right? And no matter where you are on the line, it's the same thing, right? The slope is the same everywhere. Okay, I don't know if this is helpful or not, but you can, if you write positive with a little slanty thing here, right, you can kind of remember that positive slope lines go up from left to right, right? They rise from left to right. Whereas with negative slope, the line goes down from left to right. Okay, your y values decrease as x becomes more positive. Okay, so here's another, here's an example with that. So let's look at y equals -3/2 times x plus 1. Okay, so here the number in front of the x, the m, is -3/2. Okay, so this can be thought of as our rise over run. -3 is our rise. For every 2 in the run, every 2 in the x, we go down 3 in the y. Okay, and then the y-intercept is the b-value here, so this is +1, so 0, 1. All right, now let's sketch the graph of something like this. And write your axes here nice and neat, label them. I don't know, just going out to 5 here, maybe might be good in all directions. Okay, we're gonna like kind of start at the y-intercept here, say of 0, 1. Okay, and then the slope tells us that we are going to go down 3 and then over 2. And it's always to the right on the x direction. We're not, even though the slope is negative, that just tells us that the y values are going down. You don't go left. You never change in the x direction. So we're going to go down 3 and then over to the right 2. And so there's that second point. And let's just draw this in. So 1, 2, 3, -3, and then over 2. So here's that second point right here. Then we can do it again. We can go 1, 2, 3, down 3, and then over 2. So here's another point. I like to draw just at least 2 or 3 to get enough to kind of make my line straight. And so here's what that line would look like if you graphed it. Oops, I didn't put a 2 here. All right, so again, negative, we just want to have this connection or reminder that negative slope has a line that goes down from left to right, as opposed to positive slope. Okay, there are 2 other kinds of slope. Okay, of course, you can have bigger slopes. They would make the line steeper. You could have smaller slopes that would make the line more shallow. But positive, negative have the general, either going up or down. Then we have lines that have 0 slope. So these are ones that their algebraic formula is just y equals a number. Okay, it's just y equals a number. No x's. You could also view this as like 0x plus a number. In this case, we could say -2, 0x minus 2. Because then we can see it's easy why this slope we would say is 0, right? Because there's really a 0 multiplied by the x. So here we have 0 slope. Now this isn't saying that there's no slope. It's saying that the numerical value of the slope is equal to 0. So this is 0 rise over, you can always put any number over 1, so really over a run of 1. Okay, the y-intercept is going to be, well, we basically just have b here. And so the y-intercept will be 0, -2. And so let's go ahead and sketch what that will look like. Okay, here's the y-intercept of -2 down here. So let's plot that point. And now if we go over to the right one, we rise 0. Okay, so we're just basically creating this horizontal line, right? Anytime that we move over, or if our run is 1, every time we move over to the right 1 in the x, we don't move up or down in y at all. So there's a point here, there's a point here, there's a point here. And so we get this horizontal line. And the same thing is going to happen over in this direction, right? So things that look like y equals a number. These are horizontal lines. And they, their height is determined by whatever the number is that is in the equation, in this case, -2, right? This one up here would be like y equals +4. That would be the equation of that line. Okay, horizontal line, we have to connect, remember that all this stuff goes together. Horizontal, y equals a number, and also 0 slope. Slope is equal to 0. Again, that's different from no slope, which is what we have as our fourth possibility for slope. Slope doesn't exist, or slope is undefined. This happens when you have something that is written in x equals something. Okay, so x equals a number. In this case, our run is 0. Okay, so and the denominator, no matter what your change in y is, in the denominator we have 0. So this gives us undefined slope or no slope. These typically don't have a y-intercept. And here's why. So when we graph this, okay, this is saying that x is 4, and really, I mean, y can be anything, right? There's no y equals, there's no formula to find y. So if x is 4 and y can be anything, the points that satisfy that, okay, well, here's 1, x is 4, y is 0. We can, any single y value, we can just say, well, okay, if x is 4 and y is 1, here's another point. X is 4 and y is 2, here's another point. X is 4 and y is -4, here's another point. And so when you combine these all together to get the graph of the equation, we have what's called a vertical line, straight up and down. Okay, now here you can see like the rise is basically infinite between, like how far do you go up to get from one point to the next? I mean, it's there isn't this has undefined slope. There's no way to put this into a number. Okay, so again, we want to connect vertical line with undefined slope with x equals a number all together. And yeah, so these are the 4 different kinds of lines that we can have. Let's get into a little bit more kind of mathy calculating stuff and find some equations of lines. So one thing that we're going to want to be able to do is to find slope, right? We're going to need to find the slope of a line in order to write the equation of it. Okay, so let's review the formula for slope. Okay, so again, slope is given to us or represented by m. And there are several different ways that you can find the slope of a line. Like I just reminded you of, rise over run is one of those ways. You can also think of this as the change in y over the change in x. And we use that triangle or delta symbol to indicate that. And the third way, which I like, is it's more formula-y, and it is written out in terms of the coordinates. So the change in y could be given to us by y2 minus y1, and then the change in x can be given to us by x2 minus x1. So whichever way makes sense to you, please use that. I'm probably going to use this way when we're going through problems, but whatever you like, please stick to that. Okay, so let's practice writing an equation of the line given certain properties. The first example is that the slope is 2/3. And there are many lines with slope 2/3, but we want the one in this case that passes through the point 5,7. So when we are writing the equation of a line, in the end, what our answer is going to look like is y equals mx plus b. And so what we need to do is find m, and we need b. That's our goal. We need to find what those numerical things are. Then we'll put it into the linear, the line equation. Now, in this example, we know that the slope is 2/3. So this is like a freebie. We already are given that m is 2/3. Okay, so what this tells us is that y is equal to 2/3 x plus b. We still need to find b though. Okay, so how do we do that? Well, to find b, all we need to do is plug in a point. Plug in an x and y that we are given into here after we have the slope. Okay, so let's see. We've got the point 5, 7, so that's x and y. So we're going to plug in a 7 for y. We're going to plug in a 5 for x, and then we're going to solve for b. Okay, so 2/3 times 5, that is 10/3. Then to solve for b, we're going to subtract 10/3. Okay, 7 is 21/3. Well, that's not too bad. And 21/3 minus 10/3 is 11/3. So here's our value of b is 11/3. Okay, so that means all we need to do now is plug that in back to here and present our equation that we have for our line, right? So it's going to look like altogether y equals 2/3 x plus 11/3. And here is the only line with the slope we were looking for of 2/3 that passes through that point that we wanted it to go through. Okay, example number 2 is a little bit different. We have 2 points that we want to find the line that goes through those 2 points. So here we are not given the slope, but that's okay because we can find it using one of these cool formulas. Okay, so once we do that, then we will be able to find b in the same way we did before, and then we'll be all set. So let's find the slope first. Okay, so let's find the value of m. Okay, again, I'm going to use y2 minus y1 over x2 minus x1, but you can do whatever you like if you have something else that you feel comfortable with. I'm just going to label these for myself so that I can free up some brain space for plugging stuff in. So there's x1 and y1 and x2, y2. Okay, so y2 I have as 1. y1 was 0, so 1 minus 0 up top. And then x2 was 3. x1 is -2. Make sure you have parentheses around this here because we're subtracting a negative, so we have to be a little careful. When we subtract a negative number, we end up adding it, and so this will be 1 over 3 plus 2, which is 5. Okay. Then after this, we need to find b. Again, we're just going to plug in a point. You can pick either point. It's really cool. You can choose whichever one you want. And guess what? The b value is going to be exactly the same. So when you choose, I'm going to pick this point because I love to plug 0 into stuff. It's easy. But why don't you try, pause this and plug in 3, 1, and just to prove to yourself that you will get the same value for b as I'll get by plugging in the other point. Okay, but either one will work here. All right, so I'm going to, all right, so let's just write this down really quick. So the m that we found, or the slope that we found, is 1/5. So I'm just going to put that in. Okay, so now I'm going to choose -2, 0, and I'm going to plug that in. Okay, so we have 0 for y. Make sure you put the values in the right spot. We've got -2 for x. Okay, so 1/5 times -2 is -2/5. And to solve for b, we're going to add 2/5 to the other side. And here we got our value for b already. B is equal to +2/5. Okay, so putting this all together, What we have here then is y equals 1/5 x and then plus b, which was 2/5. Okay, so in the next video, we will look at some applications or different ways of thinking about slope and equations of lines. So tune into that, and I'll see you soon.